Dear learners, welcome to the another new video lecture of Engineering Chemistry e-lecture series. We are continuing with the water softening methods. In today's video, we will discuss the part 4 of this water softening method series. The today's video includes the ion exchange process, which is also known as the demineralization process in the detail, which includes the basic principle of ion exchange process, methodology of ion exchange process, the various chemical reaction involves in removal of hardness by ion exchange process, regeneration of cation as well as the anion exchangers, and finally the advantages and disadvantages of the ion exchange process. So let us begin with the basic principle of ion exchange process. Basically, ion exchange or the demineralization is the process of complete removal of all the ions present in the water. That means it removes all the cations as well as all the anions from the water. So this process makes use of ion exchange resin for the complete removal of all the ions present in the water. An ion exchange resin, so as we discussed that in this process ion exchange resins are used to demineralize the water. So now question comes to our mind that what is the ion exchange resin? So the ion exchange resin is the cross-linked organic polymer network having some ionizable group which can exchange with the hardening causing ions. That means these ion resins, ion exchange resins, are the polymeric material with the exchangeable ions. So on the basis of the nature of these ionizable group which can be exchanged with other ions, these resins are of two types. First is the cation exchange resin and second one is the anion exchange resin. So basically the cation exchange resin is also known as the cation exchangers. These resins containing acidic groups like sulfonic group SO3H group, carbonic acid group COOH group, or the phenolic group as the ionizable group. So the basic raw structure or the raw formula of these cation exchange resin is RCOOH, where this part R is the basic polymeric part, this is the basic polymeric part, and this is the ionizable group. And in this ionizable group, this hydrogen ion can be exchanged with the hardness causing ion. So we can say that RCOOH is the common structure or common formula for the cation exchange resin, in which this is the stable part and exchangeable part is this H plus part. So this is the basic of the cation exchange resin or the cation exchanger. Since these resins exchange the cationic portion of the minerals, so therefore they are known as the cation exchangers. For example, we can see here that the basic cation exchange resin, when reacts with the calcium plus 2 ions, or we can say when the hard water containing calcium plus 2 ions passed through this cation exchange resin, this can easily exchange its H plus ion with the calcium ions. So now in the water, in place of calcium ion, H plus ion remains, while now the resin is converted into the calcium form instead of the hydrogen form. So this is the basic principle of the process, that how cation exchange resin exchanges its H plus ion with the calcium or magnesium ions, or how the cation exchange resin is useful for the water softening process. The second category of ion exchange resin is the anion exchange resin, which is also known as the anion exchanger. Basically, these resins containing the basic functional group like primary amine, secondary amine or tertiary amine group, and the alcoholic group, that is OH group, as the ionizable group. So we can say its normal structure is ROH or ROH whole twice. Both are the correct. Where the R dash part is the basic polymeric part, where this alcoholic part is the exchangeable anionic part, which can be exchanged from the anions present in the water. So basically, since these resins exchanges the anionic portion of the minerals, therefore these are known as the anion exchanger. So we can see here that ROH whole twice, that means the anion exchange resin when reacts with the anionic part then or anion, then it converts into the sulfonic resin and OH minus ion releases into the water. So this is the basic principle of ion exchanges with the reaction of the cation exchange resin and the anion exchange resins. We can easily see here that when this exchange process is carried out, the water now contains H plus ion and the OH minus ion in place of the calcium ion and the other anions. So the water is now containing only the H plus and OH minus ion, and all the other types of cations and anions are removed. That is why this process is known as the demineralization process. Now coming towards the process, that means how this process is carried out. So basically, in this process, the ion exchange softener consists of two tanks. First is this first tank contains cation exchanger, and this second tank contains the anion exchanger. That means these tanks are filled with the cation exchange resin and second one is filled with the anion exchange resin. When the hard water, which is known here as the raw water, the hard water when passed through the cation exchange resin, which exchanges its H plus ion with the calcium and magnesium ion present in the water. Thus, the water passing through this cation exchanger is now free from all the calcium and magnesium ions and containing H plus ion in place of the calcium and the magnesium ions. Why? Because when water cross the cation exchange resin, all the calcium and magnesium ion present in the hard water now fixed with this resin. So now calcium and magnesium ion hold in the bed of the ion exchange, and the hydrogen ion present in the ion exchange resin now releases, and these hydrogen ion now mixed with the water in place of calcium and magnesium ions. So the water coming out from the cation exchange resin now contains H plus ion and all the remaining anions of the salt, because we know that hardness is caused by the calcium and magnesium salt. So calcium and magnesium ions are remaining in the cation exchange bed, but the remaining part of the salt, that is the anionic portion of that salt, now coming towards the outer section of this cation exchange bed. So now this water, which contains H plus ion and all the anions, passes through the second tower, that contains the anion exchange resin. Right? So now here the anion exchange resin exchanges all the anions like sulfate ion, chloride ion with the OH minus ion present in the anion exchange resin, and now these anions are held by the anion exchange resin, and in place of these anions now OH minus coming out through the anion exchange resin bed. So now after the passing from the cation exchange resin and anion exchange resin, water contains only the H plus ion and the OH minus ions. These H plus and OH minus ions now combines to form the H2O. That is why all the cation and anions are removed by passing the hard water from cation exchange resin and then the anion exchange resin. So the water coming out from the anion exchange resin is the demineralized or unionized water. So this is the basic process of the water softening by using the ion exchange process or by using the ion exchangers, cation exchange which contains cation exchange resin and the anion exchange resin. So basically some chemical reactions are involved during this exchange process. So let us discuss these chemical reactions. See here, the cation exchange resin is represented by R dash H, where R dash is the RCOO minus and H is attached with the here. What is R here? R is the rest organic polymeric part of that resin. So when hard water is passed first through the cation exchange resin, so this hard water contains various type of calcium and magnesium salts in it. So when this water is passed through the cation exchange resin, during this passing, all the calcium and magnesium ions present in the hard water exchanges with the H plus ion of the cation exchange resin. So now the resin becomes converted into the calcium and magnesium form. Here is the magnesium. So now the resin is converted into the calcium and magnesium form instead of its original hydrogenated form. See here, that means the all calcium and magnesium ions are deposited with the organic polymeric part, while all the anions coming out through the cation exchange resin bed. So the water passing through cation exchange resin is free from calcium and magnesium ions, and now it contains the hydrochloric acid, H2SO4 and carbonic acid in equivalent amounts to the anions present in the raw water. So in this way, all the calcium and magnesium ions present in the water are removed from the water. Now second, when this water is now passed to the anion exchange resin, so all the anions present in the water now exchange with the OH minus ion or the OH part of the anion exchange resin, and now this anion exchange resin is converted in the RCl form, R sulfate form or R carbonate form, where R is the organic polymeric part. And in place of these anions, now the outcoming water from the anion exchange resin contains only the OH minus ion in place of different type of anions. Thus, the water coming out of the anion exchange resin is completely free from all the cations and the anions responsible for the hardness. So, it is known as the demineralized or the deionized water. It is as pure as the distilled water. The H plus ion released from the cation exchangers and the OH minus ions released from the anion exchanger now combines and form the H2O. So in all, the overall output from these exchangers is the H2O only. No other ion remains in the water. Now one problem coming after some time, that the anion exchange resin is exhausted, that means it converted into the chloride, sulfate or carbonate form, while the cation exchange resin is exhausted because it converted into the calcium and magnesium form in place of the hydrogen form. So regeneration is required. So what is the regeneration? Regeneration is the process by which the exhausted resin is again converted into its original form. That means the cation exchange resin which is exhausted, that means it converted into calcium and magnesium form, it is again revert back to its hydrogenated form. That is the regeneration of cation exchange resin. While the anion exchange resin which is exhausted in the form of sulfate, chloride and carbonate is when converted again into its original form, that is OH minus form, that is the regeneration of anion exchange resin. So when the resins are used for some period, they get exhausted and stop working. That is why their regeneration is necessary. So for the regeneration, cation exchange resin are regenerated by passing through it a moderately concentrated sulfuric acid or the hydrochloric acid solution. Look again here. When the regeneration process is started, the supply of hard water is stopped from here, and now the hydrochloric acid or H2SO4 is passed through the cation exchange resin. So when these acids are passed through these resins, the exhausted resin which is the calcium or magnesium formed resin now converted into its original form, that is the hydrogenated form, by the reaction of the acids passed through it, and the washings that contains the calcium sulfate or magnesium sulfate, calcium chloride or magnesium chloride are now passed to the sink. So in this way the cation exchange resin are regenerated and converted into its original form, which can be further used for the water softening process. The anion exchange resins are regenerated by passing through it an excess amount of dilute alkali solution, that is the NaOH solution. So when for regeneration process we stop the water supply from here and NaOH is supplied through here for regeneration process. So when NaOH is supplied through this exhausted anion exchange resin, this NaOH exchanges its OH minus ions with the exhausted resin's anionic part. So all the sulfate, chloride and carbonate ions associated with the anion exchange resin are converted or coming out through as the Na2SO4 NaCl, and the resin is again converted into its original ROH form. So in this way anion exchange resin is regenerated. The washings containing sodium sulfate and sodium chloride are again passed to the sink. So this is the regeneration process for the cation exchange resin and the anion exchange resin. Now what are the advantages and disadvantages of ion exchange process? Advantages: by this process water of very low hardness can be produced. Approximately around 2 ppm hardness water is produced by this method. That means only 2 ppm hardness is remaining in the water, which is the least among the processes we have discussed up till yet, that is zeolite process and the lime soda process. This process can soften highly acidic and alkaline water also. Problem like corrosion and castic embrittlement are reduced because this process also removes the anion. This is the major disadvantage of the zeolite process. So this disadvantage of the zeolite process is overcome in the ion exchange process because it can remove all the anions also from the water. Now demerits or disadvantages of the ion exchange process. It has two disadvantages. First, the equipment and chemical used for regeneration of ion exchange softener are costly. Second, the turbide water cannot be treated in this process because it may clog the pores of the resin and hence decreases its efficiency. So we have to remove the turbidity of the water before passing this water into the ion exchange softener. So these are the advantages and disadvantages of the ion exchange process. Now time for the learning check. Read the question displaying on your screen and think for its correct answer. In the determination of water using a two-bed ion exchange system, which resin are typically used in sequence? Two-bed resin system means cation exchange resin and the anion exchange resin. Option A, anion resin followed by the cation resin. B, cation resin followed by the anion resin. C, mixed bed resin only. And D, zeolite followed by activated carbon. Think for it. Yes, you are right. Option B is the correct option, that we have to place cation exchange resin first and after that the anion resin exchange resin is placed. Why? Because first the calcium and magnesium ions are removed, then the anionic part are removed with the help of the anion exchange resin. So that's all for the today's video. To unlock more awesome content, you can hit the like button and subscribe my channel. Thank you so much.